All right, so one more practice problem here. We're not doing too many of these. Again, this is just the essential learnings of our class, but you've explored a little bit on the differences between mass and weight, and there's a few practice problems, and I'm just going to do one of those samples for you. So if we go forward a slide here, what the last couple problems on assignment 4 will look like is this. And there's a few parts of this that you need to understand. So what you'll have is an 8 kilogram object. A lot of times in class, these are like parachute problems, and there's an upwards force of 50 newtons. Now, if we just stopped right now, that object would move upward, but there's a force that we haven't drawn yet. And you guys have learned that with mass and weight that force is gravity. So really there's going to be a few things that look different. You're going to have another calculation, but even though it's not drawn, we can actually always go draw that downward force of gravity, which we also talked about calling weight. And the way that you'll calculate that, we've very simplified and streamlined. What you do is you take the mass, and then the acceleration due to gravity is 10. So what you do is you take the mass in kilograms times 10. So we can go draw that downward force of gravity, or that weight, and that will be a force of 80 newtons. And we can go fill that in there. Now we can really start cooking, because again, we have a little tug of war here. We have a force of 80 newtons downward. That's our force of gravity. And I mean, maybe again, it's the parachute or whatever the upwards force might be. And you guys can see that this is unbalanced. So we know that this object's going to accelerate downwards because the bigger force is pointing down. So to go calculate, we take 80 minus 50, and then we have to make sure we can't just say 30 newtons here. The net force is going to be 30 newtons in the downward direction. If you take physics, you'll learn that we sometimes make that negative since it's going down. So now we figured out our net force. Our tug of war winner is downwards, and we can go calculate our acceleration. We know acceleration using Newton's second law is the net force divided by the mass. We just said that the net force is 30 newtons down, and this little box has a mass of 8 kilograms. If we divide that out, what that shows us, hopefully it's not getting cut off on my screen, but 30 divided by 8 gives me 3.75 meters per second. Per second is my acceleration. And since the net force is down, my acceleration would be down. So we'd want to go mark that, and sometimes we go draw a little acceleration bracket here. Just another practice problem. I think there's only 3 or 4 of those, so take your time, figure out your weight, and then apply Newton's second law.